Hi, everybody. Welcome to our presentation. And today our topic is practical ways to build Kubernetes native Java controller. And before this, I'd like to have a quick survey. Anyone who tried or considered to build a Java controller in a cluster, please raise your hand, please. Great, thanks. I see around 10 hands in this room. And that's actually much more than I expected, actually. Honestly speaking, the language we use to build the controllers in Java isn't really up to our choice, because on the one side, we hope to make best usage of the Kubernetes platform as much as possible. But on the other hand, we have a lot of legacy systems in our company. Like most of them are written in Java, and they're like running for years. We can't easily convince the developers to just switch to Golang, as we are asking them to provide a Golang SDK for us for a integration with the Kubernetes. And I don't believe yet there are many companies has tried or actually deployed a Java controller yet. But we did, and we bring it all the way to the production and to manage the underpin infrastructures in data center. And we hope by this session we can share you with some more facts and experiences about programming and running Java Kubernetes controllers and operators, like pros and cons, and also the lessons, the painful lessons we learned from it. Great. Before we dive into the content, let's do a brief warm-up self-introduction. And it's going to be started by Tony. And hi, Tony. He's a Kubernetes maintainer, and we are working in the same team in the financial PaaS platform. And he's an emeritus co-lead of the SIG CLI, focusing on CLI, multi-tenancy, and secure container runtime. As for me, my name is Min, and some contributors in the community might have known me as Yui. And yeah, my logo is always an orange cat. And I'm focusing on SIG API machinery, especially for now. It's API server flow control, CRDs, and open API facilities. By the way, there's a SIG API machinery deep dive in this afternoon. So if you're interested in API server flow control, please visit the schedule. But the open API facilities in Kubernetes API server is tightly connected with our topic, because all these Java controller framework are built upon Kubernetes official Java clients. And the client is actually generated from the published open API spec from Kubernetes. And for folks who are interested in open API schema, we will expand more about this shortly after. Okay, this is the outline or agenda of what we are talking about today. It's going to be start by general approaches to build controllers multilingually. And this is where we are going to inspect the Kubernetes operators in a high level, regardless of their languages. And this will help us to understand what Java controller framework is doing for you. And the number two is merits of developing controllers in Java. In this stanza, we will have a fine-grained comparison with Golang operators so that we can better understand why we are doing this. Like, what's driving us to probably take a shot at programming a Java controller. And number three, Tony will guiding you to experience the actual steps of building a Java controllers based on the toolings and libraries provided by the official Kubernetes Java client. And that's all from the upstream Kubernetes community. In number four, we will show you the future, what the futurists will bring or to do for better enhancements for the Kubernetes Java framework. Those works are probably like in progress, but we will be getting there really soon. So let's start by sorting out the existing controller frameworks. Let's take a look at the representatives of the existing controller frameworks today. The first one is Controller Builder. Oh, sorry, Kube Builder. It's not no doubt that it's the most popular one currently, and also the recommended approach provided by the community. And KubeBuilder is actually a binary cuddle tool that helps you initialize the new projects and new API resources in even emission webhooks by templating the source codes for the developers. The generated or the templated controller is empowered by another project named KC Controller Runtime, which is an awesome project that encapsulates and hides the underneath mechanisms like informer, list watching, and cache management for the developers. And Operator SDK is used to be really popular framework, and it's now under active maintenance. And I think we really didn't have much experience using these projects, but I think the KubeBuilder and Operator SDK looks really close to us because they are basically doing the same thing from the user's perspective. And the third one is API Server Builder Alpha. And, the third one is API Server Builder Alpha. The KubeBuilder project is actually a precedence of this project. And the API Server Builder Alpha is developed by Googlers in the beginning, and its feedbacks and drawbacks are successfully addressed in KubeBuilder. But this project is still under active maintenance. But this project is mainly aimed at helping users to build new resources based on API server aggregation. Yeah, you don't have to do every line of coding from the very start. These toolings will help you to do the templating, and what you just have to do is fill in the blanks in the templates code. And if you know more about Kubernetes project, there's a example controller hiding in the tree. It's working, but if you really want to develop a controller like that, you have to do a lot of copy pasting and tons of triple works like that. And in the next stanza is a really interesting project, and I think we can call this a callback-based controller. And there's an interesting project named the Meta Controller. In this project, developers won't have to develop, build, or compile a whole controller anymore. What you require to do is just to simply implement a webhook and wait for the central caller to notify you when you need to reconcile something. So great, let's list them on the table and have a good comparison between the two. As you can see in the screen, let's start by the first two rows on the table. Builder-based controllers are actually helping users to, with the step one of building controller, but it doesn't handle how to continuously manage operators' lifecycle, like upgrading. KubeBuilder generates a working deployments YAML document for use and let the native deployment controllers deal with all the other stuff. Well, in the callback-based, it's taking over and decoupling the operator lifecycles for management from the developers, so that you can majorly have to care about is the availability of your webhooks. And yeah, but that comes at the cost of deploying an actual deployments in your cluster. Okay, let's come to the rest part of the table. As you can see, what the builder-based controller helping you is to help you build a complete standalone binary, and it's doing well in scaffolding, test solution, list watching, and the cache management. Well, last but not least, as for multilingual, sadly, how does the tool pattern works for multi-programming languages? For callbacks-based controller framework, developers are only required to write a server implements simple HTTP or HTTPS protocols interface, which is really simple nowadays now. And on the other side, sadly, builder-based controller doesn't work across languages. So we will have to implement a complete builder libraries per programming language. And for example, the controller runtime is written in Go, so it naturally requires the developers to write their controllers in Go. sadly, for nowadays, Java developers doesn't benefit from that. So that what we are doing is to port those mature controller libraries to Java world and make use of the merits of Java like object-oriented programming languages as much as possible. Okay, here's another question. So how are you, why are you saying that you are porting libraries from Golang to Java? Is there any improvement for us to do so? Yes, I believe, and I listed several items on the screen. Let's expand them one by one. First one is the heap dumping. Currently, the full or complete heap dumping is not supported in Golang. Even though Golang provides really useful toolings to do the profiling on the running processes, but we can analyze the overall tracing of memory allocations or CPU consumptions, but that's not full, that's not complete. Instead, in Java, because of a memory management is running on JVM, a higher layer on the operator system. So with the help of that, we can simply checking out what is happening on the heap, what is happening on the stack with the toolings like Eclipse, Mat. This is really useful. As you can see in the screen, the left side is Java, and using the Mat's toolings, you can easily find out what's the status, the detailed status of every object. This will help us to do some fine-grained debuggings, like when you want to check out what's stuck in the informer's work queue, the controller's queue, and for a running Go process, it's almost impossible to finding out what is happening over there. And also, you can find out what's missing in the cache entry. So if you dig further into the Kubernetes informers, you might probably know that informer is not always good. It can miss its cache entries. It may involve disturbance into the upper infrastructures. Okay, and so with the help of Java heap dumping, we can do a detailed troubleshooting. On the right side, there's beautiful pictures printed by Go toolings. They're like memory allocations and CPU consumptions. They looks really good, but it won't help us to find out what's the detailed status inside the controller. As for the performance, the second one is performance diagnosis. So I listed the Prometheus metrics on the screen. On the left is the Prometheus JMX exporter. As you can see, obviously the number of Java is more than Go. But let's compare the supported Prometheus metrics on the runtime. In the conclusion, Java does better in capturing what is happening in GC, but on the screen there's can you guys see my? Okay, there's only 2 metrics over here in the screen. That's for GC. Yeah, that's sad for Go developers, but for Java, you know that we can easily replace the GC engine, and there's a whole lot of metrics for debugging Java GC processes. But either ways, both in Java and Golang, you are required to have a deep understanding of the memory management model of the both languages. Okay, let's jump to the thread model. The Java thread is running as a state machine driven by external calls. A thread can be interrupted immediately by another by sending a signal. While in Golang, it's tough to shut down a Go routine proactively. Interfering the states of a running Go routine is almost impossible currently. You will have to do something like a select a channel and stop quit exit a Go routine when a stop channel returns. But practically, unlike the Go applications, the Java application won't usually have a happy ending because when it comes to starting, it takes operators more times to shut down. And it's in the Go world, it's a common thing to have operators loop crashing sometimes. But in Java, it's almost unbearable. Like if you develop a Java application, you won't easily allow it to keep crashing in the Kubernetes cluster. That's also unbearable in our company. But in Golang, especially in an HA setup, operators are normally working by locking a resource. Yeah, in Kubernetes, we call this a leader election. I don't pretty much agree with that. That's not actually a leader election from my view. Yeah, but Golang operators are really good at crashing. It doesn't matter how many times it just crash. Never mind, there will be a leader, doing all this stuff. Yeah, in Java, because the thread lifecycle can be managed by external calls, we can do something like you can completely shut down a Java controller without just restarting the container. You can manage the worker thread in a fine-grained manner. Okay, the next one is inheritance and generics. Apparently, Go doesn't know anything about it, and there's a question mark. But in Java, there's a lot of, Java is an object-oriented language, and it has the benefits to program when you are implementing a lister or informer, you will just have to pass the node and pod some resources as a type parameter, and you don't have to in Go we're using a code generator to generate all the stuff. Those generated code are really duplicated, and that's all because Golang doesn't fully supports any inheritance and generics. And as for the open source resources, yeah, Apache has been running for years, and there's many successful open source project resources. Even though some of them has been lost the maintenance, they are not actively maintained. Yeah, but still Apache's resource is much more than the CNCF provided for now. So let's back to the business. What our Java controller framework is providing is many libraries which is ported from Golang. We are not planning to invent or reinvent the existing client libraries like Informer in the foreseeable future. And what we are trying to keep it is just to make it the same as the Go libraries as much as possible, so that Java developers can use it out of the box and do anything just Golang developers can already do. By the way, I think there's a barrier between the two languages for now. Java, actually, Java developers can think that they may be good at redefining the things Golang libraries have already did. Yeah, vice versa. But at least we can just start by acquiring the same capabilities Gophers can already do. And it's going to be a quick demo from Tony about how to actually use our Java controller frameworks. And hi, Tony.
Okay, here I will do a quick demo of how to use Java SDK to write your first Java operator. I think I have to ask Kimi to hold this microphone for me, as I have to type the code.
Okay.
Okay. So, here in my laptop.
Oh.
Okay.
You have to quit the presentation mode.
Okay. Okay.
Yeah.
So, can you see? So, here in my laptop, I have a local Kubernetes cluster Yeah. Also, I have initialized Java project with some necessary dependencies, as you can see here. You have to add client Java API, and client Java extended, those three modules to your project maven dependencies.
So for a second, so as you can see in the screen, the POM dependencies declares that there's a IO Kubernetes group and artifact ID is Java client Java. That's the official Java clients we are talking about. And on the screen, the version is 6.01. That's the latest for now, but we'll be releasing a 7 really soon, probably this week or next.
Okay. Once you get all these dependencies, you can start writing your reconciler. So here we go. Let's just create a simple node reconciler. So we just print out the node name. All you need to do here is just insert the reconciler interface.
So the reconciler interface is basically the same as the, if you know about controller runtime, their interface is almost the same.
Okay, we have to inject the node lister so that you can get this node through the background informer.
Please notice that the informer and the listers are declared by type parameters, and there's no a single class for them. So what Tony is doing is adding a... He's too busy at coding.
Okay. We just finished the reconciler, right? And here the result false means that you have no need to include the object at the same time. Okay. So we just finished the reconciler. The next step, you need to write a controller to call back reconciler. And of course, before you write your controller, you have to create the background informer. And you may notice that we have already added this here. Okay, which is a little bit different from Golang controller as there is no generated node informer. You have to create it manually. But thanks Lambda and the generic, so you just need to write a piece of code to create a load informer. Okay, simply as a reconciler, you can quite easy to create a controller with the controller builder. Let's just create one. So we use the controller builder, and you can specify the controller name. Also watch node resource. Here we use a Lambda function. Also, you have to band the reconciler to this reconciler to your controller. Also configure the reading function. And just don't forget to call the build method.
So if you got any question about the code, we can address it in the Q&A session. Thanks.
Okay, we have the controller, we have the reconciler. The last thing to do is to add this controller to a manager and start it. So let's just try to. Add this node controller. Okay, build one. I'm supposed it's to work. Okay. So let's just give it a try.
Let's see if the controller is working.
Okay. So
you will see a continuous notification on the screen because the controller is basically at least watching the nodes, and the node is actually continuously updated because of the node heartbeats. So every time the node has a heartbeat, we will see a print message on the screen.
Okay. So I think the controller is running. You can see node name for each node status update. Okay, that's quite easy, right? Okay, let's just switch to the PowerPoint. Right. Okay. For the future enhancement, there are already some work items in the roadmap. I think Kim is working on OpenAPI version 3, which brings more powerful features like multi-returning, onboard list or string. Once this is done, the Java controller will switch to that new version OpenAPI schema. Also, we did notice some memory or performance issue in large size cluster. So we are working on some customer object serializer, which can drop the fields which you are not interested in to make the operator more memory friendly. Okay, and about the controller deployment, we are working on some gallery release. We try to integrate the gallery release strategy with your operator deployment. So then you can control how you can deploy your operator to the cluster in case that there is some issues with your new version operator. Okay, more work, I think more work to do, so contribution is welcome. Okay, I think we just finished. Any more questions?
There's only one mic, so if you have questions, it's best to come up here because we're going to have to trade the mics.
Great. Anyone got any questions? If you got any more question about the classes, about the usages, they are fully documented, so they can check out their usage on the doc. Thanks.
Yeah, thank you. It's actually more of a statement than a question. First of all, great work. I very welcome this. And you're definitely not alone. And we also are working in the company at a Postgres operator, and we're building it in Java because that's what our expertise is. So, and I've already talked to some of the people who are willing to commit some efforts to kind of a Java operator framework. And so far, we have included most of the things that you mentioned, including OpenAPI. We're including webhook, also validation, and a few other bits out there. So definitely very interesting efforts. Let's work together on this.
Thank you. Thank you. So our project is always opening to the community. So if you got any better implementations, we are always welcome. You just mentioned some advances. Sorry for a second. Do you completely implemented the informers or the controllers, or just like the plain reactive programming in Java? So there's a problem here. I'm sorry.
Can I just take this? Folks, before we continue the Q&A, just want to remind everybody to rate the talk on Sketch. I should have said that to get started, but here you go.
Thank you. No, I just want to say that, first of all, it's a work in progress, and second is following a more reactive programming model right now, and it has some differences. It's based on Fabric 8 instead of the official Java client. It's not targeted to, but it's using Graal VM for native compilation as by default, because that's what we wanted. And there's many different approaches to building these things.
Thanks. There is many successful reactive programming frameworks in Java today, but just as you say that it's not actually a complete equivalence of the Golang informers. That's probably a problem here because if you check out the implementation of the underlying informers and the indexers in Golang, they are designed really well, and it's complicated. It's not just like pushing events and execute something on notification. All the controllers and operators are designed to be running in a stateless way. The events can be deduped. For example, if you have multiple update events in the queue, they can be squashed into one. So many stuffs like this. So there's a lot of extensions in Golang's informer comparing to the plain reactive programming frameworks. Yeah, we'd love to see if you are willing to contribute these features to the community. We're always welcome. We have the bandwidth for reviewing and merging your pools. Yeah, well, thank you.